Okay, guys, let's go ahead and start talking about some chemical formulas and how we use them. This is section 7.3 out of your book. Now, the three things we're basically going to be looking at today, we're going to be looking at our formula mass, our molar mass, and our percent composition. Now, when looking at these guys, the formula mass and molar mass are basically the same thing. The only difference in them is that the formula mass is the mass of one unit of a compound measured in AMUs, and molar mass is the mass of 1 mole of a compound measured in grams. Okay, and they're numerically the same. So if we say that we have 15 AMUs, that means we also have 15 grams per mole. So they're basically just the same thing, just different units. Now, percent composition is the percent of an element present in a compound. So basically what this tells us, if we're looking at water as an example, percent composition tells us, well, how much hydrogen do we have in that water and how much oxygen do we have in that water, and it's going to be a percent. Now, for the formula mass, what we do to find it is the sum of the atomic masses of all the elements in a compound. Now, we're going to take, for example, water, H2O. Now, we know that oxygen has a mass of 16 AMUs, and we know that hydrogen has a mass of 1.01. So now to find the formula mass, all we have to do is just add up the mass of each of these. So oxygen, obviously we only have one of them, so the mass is just going to be 16. Hydrogen, since we have two of them, we'll multiply 2 by the atomic mass for hydrogen, and that will add up together to get the sum, because remember, sum means addition, and that will give us 18.02. Now let's go ahead and do a little bit more practice. Now we're going to start here, and what we're going to do is we're going to determine the formula mass for the following compounds. Our first compound that we have is sodium chloride. So how we would start this out, we would say that we have sodium and we have chlorine in the compound. Okay, and we know that since they don't have a subscript, it's an understood 1, and both of them are just 1. Okay, then we look on the periodic table and we see, hey, sodium, and we're going to round everything to 2 decimal places, is 22.99, and we see that chlorine is 35.45. We go ahead and multiply those guys out, and we'll get 22.99, and we'll get 35.45, and we add those guys up, because remember it's a sum, and we should get something right around 58.44. And remember, it's formula mass, so the unit is going to be AMUs. Now, let's go ahead and work the next one. We have CO2. CO2 stands for carbon dioxide. So that means we have carbon and oxygen. And we have 1 carbon and 2 oxygens. We know that carbon has an atomic mass, because we found it on the periodic table, of 12.01. Remember, rounding to 2 decimal places. And oxygen is 16.00. So we go ahead and multiply these guys out, and we'll have 12.01, and we'll have 32.00, and add those guys up, and we will get a formula mass of 44.00, or sorry, 01. Remember that is AMUs. And then lastly, we see we have C6H12O6. So we set it up the same way with carbon and hydrogen and oxygen. And we have 6 carbons, 12 hydrogens, and 6 oxygens. Go ahead and multiply those guys by their atomic masses on the periodic table. And that gives us a total of, what, 72.06, 12.12, and we will have 96.00, which will give us a total of 180.18. And remember, that's AMUs. Now, written all nice and neat so you can see all that work written out in front of you. If you need to, just pause it right there and write everything down. Now, moving on, we're going to go on to molar mass. And remember, we said that formula mass and molar mass are numerically identical to each other. But remember that we just change the unit. Change it from AMUs to grams per mole. Now, it can be used as a conversion factor between moles of a compound and the mass of a compound. So for example, it says, how much mass would 2 moles of water have? Now we're going to go ahead and work this out the whole way, even though we already know what the molar mass of water is because we've done it previously. But we're going to go ahead and work it all the way out. Now water is H2O, meaning we have hydrogen and oxygen in the compound. Okay, and we have 2 hydrogens and 1 oxygen. We multiply those guys by their molar mass, which is on the periodic table, which that equals 2.02 and 16.00, which gives us a total of 18.02. Now, what that means, that unit is grams per mole, which if we were to rewrite this and just out lengthwise, what that means is we have 18.02 grams of H2O in 1 mole of H2O. So to work this out, all we have to do is we have 2 moles of H2O, and we know that we set up our boxes to do conversion factors. And since moles is on the top, we'll go ahead and put moles on the bottom from our conversion factor. 1 mole of H2O. And then we have 18.02 on the top, because we got to put the other side on the top. And multiply that out, and we should get an answer of 36.04 grams. Now, let's go ahead and work some more examples. Here it says, what would be the mass of 1.5 moles of C6H12O6? Now, we've already done the formula mass for it, and we found out that the formula mass, we had 180.18, and that was AMUs. But here we need the molar mass. So we're going to go ahead and convert that and say that's grams. And we know that that 118.18 grams equals 1 mole of our C6H12O6. So to set this up, it's very simple. We have 1.5 moles, and it's of this, equals. Now, since moles is on top, we put moles on the bottom. 1 mole of the C6H12O6. And that 1 mole equals 180.18 grams of C6H12O6. And we multiply that out, divide by the bottom, and we should get 270.27 grams of C6H12O6. And our last example of conversions. Here we see we have how many moles are in 22 grams of CO2. Now we've already found the formula mass of CO2. We said that it was 44.01. We'll change it to molar mass since that's AMUs, and all we have to do is go grams of CO2 equals 1 mole of CO2. So don't have to do any more math on that, and set it up, and we have 22 grams of CO2. And since grams is right here, we have to put grams on the bottom. We'll have 44.01 grams of carbon dioxide equals 1 mole of carbon dioxide. Oops, sorry, big O. And multiply that out. We'll have 22 divided by 44.01, because remember we multiply here and then we divide by the bottom. And we will get something right around, rounding the 2 decimal places, of 0.50. And remember, those units cancel right here, so the unit we're left with is moles of CO2. Now, percent composition, remember we're looking at the parts divided by the whole. We're wanting to know how much each element contributes to the formula. So the way we find this number is we divide the atomic mass of an element by the molar mass of a compound, and then we multiply it by 100. For the example that we have here, it says what is the percentage of hydrogen in H2O? So we know that the molar mass is 18.02. Okay, we got that by doing this. We have hydrogen and oxygen. We have 2 hydrogens, 1 oxygen. Remember, we got their atomic masses from the periodic table. And we multiplied those guys out and added them up. And we see we have 2.02 and we have 16.00. Add them up, and we got 18.02. So all we have to do to find the percentage of hydrogen in H2O is we take our 2.02, divide it by our whole, which is 18.02, and we multiply that entire thing by 100, and we will get a percentage of 11.21% of hydrogen in water. So all we did was we divided the part by the whole. Okay, so let's work in another example. Here it says determine the percentage of each element in H2SO4, which we know H2SO4 is sulfuric acid. So we have hydrogen and sulfur and oxygen in this formula. We have 2 hydrogens, 1 sulfur, 4 oxygens. We multiply those by their atomic masses on the periodic table. And we go ahead and multiply them out. We'll have 2.02, 32.07, and 64.00. And go ahead and add those up, and we should get 98.09. Then all we have to do to figure out what we have is we divide the parts by the whole. So we're going to divide by 98.09 on each of them. And then multiply that number by 100. And we should get the percentages of hydrogen should be 2.06%. Sulfur should be 32.69%. And oxygen should be 65.25%. And guys, a good way to check yourself, add those 3 numbers up. If it equals 100%, then you did it right.